Hey guys, you are with the Tech Science. Today we are discussing a new point based on the chapter metallurgy for the class 10. In the metallurgy chapter we are discussing that extraction of the metal from its ore, and that in the thing what called like the term it is called metallurgy. Basically we are discussing one more chart is there also. In that chart we find out that the metals are basically divided in three types. Some of the metals are there, they are called like the highly reactive elements. Some of the elements are there, they are called moderate reactive, and some are the less reactive. So the today's discussion point is the extraction of the moderate reactive element. Generally in that chart if you found some of the names of the moderate reactive elements are like iron, copper, zinc, lead, etc. So here as an example we are taking we consider zinc. Okay. Now these are the elements which are called moderate reactive. Generally in nature they are in the form of their ore, either in sulfide salt or in carbonate form. Okay, so these moderate reactive elements are generally they found in either in sulfide form, sulfide salt, or in carbonate form. So as a zinc we can take both example, because zinc present in sulfide form like ZnS, and carbonate form it is ZnCO3. You can take any example or we can consider both of these right now. Okay, zinc is one of the example. So using that example I will explain in front of you how the extraction of the metal exactly is there. Okay, now if the metals which are called moderate reactive, as an example we take as a zinc, it is formed in sulfide as well as the carbonate form, but extraction of the metal from its ore either in sulfide form or in carbonate form is somewhat difficult, rather than if you are converting these like ores, if it is in oxide form, in their oxide form, then it is very easy to extract the metals which are called moderate reactive in the oxide form. It's very easy, and for the reason you are using either two processes. First it is called roasting process, or you can use the process called calcination. Okay, so if the elements is there, like metal is there, and if it is moderate reactive, and suppose if it is sulfide form, so apply the roasting process so that it is converted into its oxide form. And suppose the elements moderate reactive metal is there, and suppose it is in carbonate form, then apply the process of calcination, convert it into the oxide form. Now question is what is the concept, what is the meaning of the word roasting and as well as the calcination? Roasting means like heating, strong heating of this metal. How? It is strong heating of the metal in the presence of air, This is what it is called as the roasting process. What is calcination process? This is also the same. The strong heating of metal which is moderate reactive in a limited supply of air, So that is what the basic difference in between the roasting and the calcination. So roasting is what? Strong heating of the metal in presence of air. Means here sufficient amount of air is there, and here limited supply of air. If you strongly heat it to the metal, you form the carbonate forms convert into the oxide form, and here sulfide form with the help of the roasting process converts into its oxide form. For example, how the sulfide get converts into the oxide form with the help of the roasting. So there is an example. What is that? ZnS. This is what? ZnS, when it burn in a presence of oxygen, because here there is a presence of air. So when zinc sulfide burn in presence of strongly heated in presence of air, what happened here? The zinc oxide has been formed along with the liberation of sulfur dioxide gas. Okay, this is what the reaction. If you want to balance the reaction, you can easily balance, like this is where 2, here 3, here 2, and here 2. I am directly writing because already have uploaded the video how to balance the chemical reaction. You can see that. Okay, so observe here. So sulfide metal which is in sulfide form, it get converts into the oxide form. In the same manner, when the zinc it is in carbonate form, that is called ZnCO3. So you just strongly heat in a limited supply of air. What you found? You found zinc oxide along with the liberation of carbon dioxide gas, which is already balanced. So this is what the proof, how the roasting and calcination process converts, the roasting process converts the sulfide ores into in oxide form, as well as the carbonate ore into its oxide form. So we done the 50% work here. So what we did exactly, we moderate reactive element, example zinc, which is in sulfide salt or carbonate ore, we convert it to the oxide form. Why? Because just I told you, because the extraction of the metal which is in oxide form, so it is very easy method to extract the exact metal from this oxide form compared to sulfide or carbonate form. Now observe, so this is what the half method that we already did. Now question is what we have to do after oxide form. Once you got the metal after from sulfide or carbonate into oxide form, not what we do, we have to use some kind of reducing agent here. We have to use some kind of reducing agent here, and when you use the reducing agent from the along with the oxide form metal, then you found pure metal. You found pure metal because here some kind of displacement reactions occur. So you can use any suitable reagent. Example, this zinc oxide which is obtained either from sulfide ore or the carbonate ore. So you can use carbon as a reducing agent. So when zinc oxide reacts with the carbon, a kind of displacement reaction occurs, and here the zinc gets separated along with the formation of carbon monoxide. So from the sulfide or the carbonate ore, first you got oxide form and finally you got the pure zinc. So within these two steps you can extract the metal from its ore either in the form of carbonate or in sulfide salt, which is an example of moderate reactive element. So now question is what? Can you use reducing, which kind of reducing agent we can use? So we already told you, you can use any suitable agent. Instead of carbon you can use sodium. Instead of sodium you can use aluminium, etc. So a suitable reducing agent is required to extract pure metal from its oxide form. So this is what the today's topic, extraction of the moderate reactive element. Suppose I have to be like summarize this complete point in a very simple manner, so we can prepare a chart. What is the chart? Observe here. This is what the moderate reactive element, and moderate reactive element either in sulfide form or in oxide form, right? Sorry, carbonate form, either in sulfide or carbonate form. Now apply the process of roasting here and converts into the zinc oxide form. Okay, converts it into the oxide form, as well as when it is in carbonate form, again you have to convert it to the oxide form with the help of the calcination process. And once it converts into oxide form, use the reducing agent. Use any kind of reducing agent along with the displacement reaction occurs here. Displacement reaction occurs here, and you found the pure metal, which is completely moderate reactive. So within this chart you can clarify the extraction of moderate reactive element. It's very easy. Element moderate reactive either in sulfide salt or carbonate form. If we apply the process of roasting, convert it into oxide form. If it is the form of carbonate form, convert it to the calcination. Use the calcination process, convert it to the oxide form. Once you got oxide form, use a suitable reagent, reducing agent, and use the extract it using the displacement reaction, and pure metal you obtained. So this is what the today's point. I hope you understood this point. If you like the video, please subscribe my channel and press on the bell icon for the new notification. Thank you.